Welcome to another episode of the MEGIN Spotlight series. Today we're really delighted to have Caitlin Baltzer, co-founder and COO, and Dr. Ben Dunkley, Chief Scientific Officer of MYndspan. MYndspan utilizes MEG technology as part of their service to provide people access to information about their brain function. Hi Caitlin and Ben, thank you for joining us today.
Hi Gabs, thanks for having us.
Thank you so much for inviting us on. Great to be here.
So let's kick off with the first question then. So how did you first become exposed to MEG technology?
I guess I'll take that one first, Caitlin. So I come from a background in psychology, and I was really interested in consciousness and visual perception and how the brain works and philosophy of mind and all those sorts of like deep, meaningful questions that you try and ask yourself when you're a teenager. And through university, that was something that I continued to study. And I was really interested in how the brain really encodes this information and allows us to see and interpret the visual world. We have all this incoming information that comes through our eyes, goes through our brain and goes to the visual part of the brain. But how does it decode it? And I started asking questions about what was unique about the brain, and realized that we have a number of different tools in neuroscience and neuroimaging specifically about how we can measure this. But it seemed like to me that the real key to this was brain function or neural activity, was how that these states are encoded and how our consciousness was served. And people talk a lot about brain waves, you might have heard of them. And this seems like a really nice explanation for how the brain might work. So I was really fortunate to actually get an MRC studentship to go and study neuroscience and neuroimaging at Aston University with Professor Gareth Barnes, who's now at UCL, a massive name in the field and an amazing guy. So I was very lucky to sort of work as his student under his supervision during my master's, and that was really my first exposure to MEG, and just found what an amazingly powerful technique it was for answering some of these basic neuroscience questions. And then was very fortunate to follow on from that to go and work in Cardiff at Cardiff University at Kubrick with Professors Krish Singh and Tom Freeman, asking similar questions about brain states and how it interprets the visual world and questions of consciousness and so on and so forth. So that was really my first exposure to MEG as a technology and its use in cognitive neuroscience and asking deep philosophical questions about the mind. I didn't ever really solve any of those questions, I don't think, but that was my first exposure to technology and been using it ever since, really, and sort of moved more into clinical neurosciences now to study PTSD and mild traumatic brain injury. And that started with Doctors Margaret Taylor and Liz Pang at Sick Kids.
What about you?
So I have a far less prestigious background when it comes to MEG and MEG technology. I've only been in the industry for about 5 to 6 years. Prior to this, I was in finance and investment, which is where through a family connection, I ended up working on an acquisition of a company and where I first discovered MEG through the due diligence process. I really learned all about the technology and really became enamored with it. And so I decided to join the exciting industry after that acquisition full time, which is when I had the opportunity to learn from and work alongside the incredible team at MEGIN prior to doing what I'm doing now.
So let's dive into what you guys are here for today. So can you tell us about MYndspan? So why did you choose MEG as the integral modality to MYndspan, and what information is presented to people about their brain health utilizing your service?
Yeah, so I'd love to. So MYndspan is a data analytics and wellness company. I've always been the type of individual to wear an Apple Watch and an Oura Ring. I track various different aspects of my health, but our brain controls all of these areas of our health, and we have no way to track the brain. So with MYndspan, we've built a consumer service to do exactly that. How it works is that an individual makes an appointment on our website. They come into a partner MEG site. They do 20 minutes on our iPad app, filling in some personal data that gives us some context to the brain activity. Then they do some cognitive tests, measure things like spatial skills, working memory. And then they sit for a 10-minute resting state MEG scan. This is uploaded to our platform where it's combined with the information we've collected on the iPad. And then in about 24 hours, that report is in our client's inbox, which outlines the scores of their cognitive skills, but it also importantly measures the localized brainwaves and activity in the neural networks. But I am what I call a MEG muggle. So maybe Ben, you can give some more information about the background on the measures we use and why MEG's the best.
I think you do yourself a disservice, Caitlin. That was fantastic. Yeah, to really sort of build on that, we do increasingly think of the brain as controlling all these different aspects of our behaviors, of our cognitive states, and conversely, we realize now that neural dysfunction underscores a lot of psychiatric or neurological challenges, right? And one of the best ways, really one of the unrivaled ways of looking at this is MEG. So we measure a lot of different aspects of brain function. There are many, many different ways in which you can capture this information. But, MEG really does provide a way to look at this, the neural dynamics, and neurons are really, the CPU of the brain. They control a lot of the behaviors that we generate, all our memories, all of our thoughts and emotions. As I think Caitlin said, people come in and they do a resting state scan, which is really a very well tolerated protocol without too much complexity to it. And it's a case of lying in the scanner pretty much for about 10 minutes and thinking within your own thoughts. And MEG is proven to be a really well tolerated modality for imaging this kind of brain function. In my lab, we often look at people with anxiety related disorders, PTSD, and potentially lying in, say, an MRI board can be quite not well tolerated, should we say. We've had multiple cases of people feeling quite claustrophobic in there, but MEG, is fantastically well tolerated. There's very little noise. So we have people lie in the scanner and we pull out aspects of brain dynamics and brain functioning, multiple different types of neural markers related to aspects of the mental state, as well as psychopathology, neuropathology, those kinds of things. And we could take, for example, concussion. There's a lot of interest in the world right now, particularly in the UK, related to the concussion crisis in contact sports. And we know that there are certain neural markers related to that, such as neural slowing, we might say, where the activity of your brainwave slows down to a degree. And this is one of the putative markers. And we look at that, we image that, for example. But we also know that, again, as concussion as an example, is multifaceted. It's actually quite a complex disorder with quite a dynamic sort of recovery state. People often display protracted symptoms and recovery. And we know that these slow waves, for example, are related to disconnectivity and deafferentation, so underlying neural damage. But as I said, it's multifaceted, and there are other aspects of the disorder that also impact aspects of excitability of the brain. There's excitotoxicity, there's neurochemical changes, neurochemical and neurobiological cascades. And there are other things that impact subsequent to that, such as changes in inhibition, and we can image those with MEG, and this is what we pull out as part of our MYndspan service. So we really pull out a number of different multivariate markers, and as Caitlin said, in a statistical speak, we use a multivariate approach. We also capture other indices related to cognitive abilities, related to general functioning, such as sleep and diet, as well as BMI. And in future, we hope to combine these and build prognostic models. So to say, you're well on your way to recovery, say if you sustain a concussion, or potentially, you might be at risk for cognitive decline, or you might be going on this path towards optimizing your brain function and general health. So we really do take this kind of really umbrella multivariate approach to data capture.
Thank you. So this is very much consumer focused. So you are an advocate for people empowering themselves with information about their brain and how it's functioning. Can you elaborate a little bit more on why you feel so strongly then about this?
Yeah, I can take this. This is something I feel incredibly strongly about, probably because I grew up as a competitive swimmer. I measured everything, whether it was my swim times or different aspects of myself, just to be the healthiest and best competitor I could have been. And really objective measures were the key to that, to knowing where I was with my race, where I was going, where I needed to go, and how to get there. And this mentality really lends itself to health generally. So now I could go into the fact that brain and mental ill health are the leading disability, or the leading cause of disability worldwide, that it costs the global economy 2.5 trillion annually. But on an individual level, our brain controls every aspect of our health, and it's the body's control center. And ultimately, we want to be in control of our health, and understand how the brain is functioning is pivotal to that. And that information is your data about your body. And I think everyone deserves to have access to that, to really leverage the incredible insights that it has to offer, to allow people to feel the healthiest they can feel and the best they can be.
So that leads straight really into the next question, which is, where and how will your service be made accessible to the consumer then?
Yeah, so at the moment, we offer our service in Toronto, Canada, and Birmingham, UK. We've partnered with Meg sites in those cities. But ultimately, our goal is to make this as accessible as possible with additional Meg sites going forward. So we hope to announce kind of the expanding service soon.
Well, that'll be exciting to hear about that next then. So in addition to these plans, MYndspan is also involved in providing MEG data processing as a service. Can you expand a little bit on that and this automated resting state pipeline?
Sure, I can take that one. As we just said, really MYndspan, I guess, is client focused, but we absolutely work as sort of a research organization too that can process MEG data and return to, say, researchers interested in studying brain functioning and clinical groups, those kinds of things. And we've basically built out a fully automated scanner agnostic workflow that allows us to process resting state data, and it's built on some of the most advanced cloud computing platforms and uses open source toolboxes such as Python. So it's quite a simple process, really. The MEG operator at site would upload that data to the cloud, and it's automatically processed, in a very short time frame, less than an hour, I would say. And we use a number of rigorous quality assurance protocols that checks for some of the pernicious artifacts that you might get in MEG data, such as head motion, which can corrupt the data to a degree, bad channel detection, so it detects noise in the sensors and omits those, co-registration errors, which involves figuring out where the brain is relative to the sensors, amongst other factors. And this is all a fully automated process. We also use very rigorous noise removal algorithms such as ICA, where we extract physiological and non-physiological sources of noise, so we get rid of all that interference in the data that would otherwise swamp the brain data. So this is, again, all fully automated, and we remove ocular artifacts, cardiac artifacts. So those are things that we're not really interested in, right, when we're looking at brain data. And this is based on threshold-based epoch rejection, and automatically this is generated and put into a QA report, and it allows the user to check sort of co-registration errors related to the head placement relative to the sensors. This is all generated automatically, and then we use a LCMV beamformer, which allows us to extract virtual sensors from different regions within the brain. So there are many different regions of interest, and we pull that time course data from each of those areas, and then we can look at sort of network architecture, so how different regions of the brain are communicating, their activity profiles, and this is all returned to the user in a simple CSV data format, so then they can use that data to apply statistics, look at network architecture, look at regional function, potentially compare groups if they have different groups of interest. So it's a really powerful tool for researchers as well to use in processing their MEG data, and it really does a lot of the legwork, and takes away a lot of the laborious aspects sometimes of checking data quality. So that's all completely automated and returned to the user in a quick time frame. I mean, compared to how long it used to take when I was a master's student, when it would take all night to run one data set potentially, we've seen a massive reduction in the processing time over the past few years.
So then, do you think that any areas you feel may support this with the new clinical applications for MEG in the future?
Absolutely. So, as I'm sure all of our viewers know, really, the current clinical use case of MEG is, I guess, seizure localization, surgical resection, pre-surgical functional mapping of eloquent cortex, finding out where the language centers are, the motor centers are, so those aren't resected during surgery, be it for seizure, epilepsy, oncology, those kinds of things. But MEG does have a huge amount of potential in understanding other clinical disorders. And as far as I'm aware, it's now being used in Amsterdam at their medical center, their Alzheimer's center, for supporting differential diagnosis of different types of dementias, right? Potentially separating out Alzheimer's from frontotemporal dementia, from Lewy body dementia, and so on. So these are all disorders that might have similar symptomatology, changes in cognition and memory, but differentiating them can be quite difficult, and there are certain things that might be used, like tauopathy or cerebrospinal fluid, spinal tap, for looking at particular biological markers. but that might not be well tolerated by people. So in those cases where a differential diagnosis is important, but they could lie on either side of this classification, MEG is now being used to differentiate those groups. So that's a really important use case of emerging clinical use of MEG. We are developing something similar within my lab. For example, we look at a lot of PTSD, operational stress injuries in the armed forces. Mild traumatic brain injury and concussion is a huge problem, similarly in the military. But they present often with a lot of overlapping symptoms. But one's a psychiatric diagnosis, psychiatric disorder, and one's a neurological disorder, right? So their treatment pathways vary quite widely, and particularly for PTSD, it can take a long time to establish an effective treatment regimen. So we've published some data recently and been using MEG to try and differentiate those cases. For example, we can actually pull out, and this is what we use, and some of the markers we use in our MYndspan service, some markers of neural activity that really quite quickly and easily distinguish MTBI from PTSD. And the other use cases, and this is perhaps further on in the future though, will be in the use of precision medicine. For example, major depressive disorder, treatment-resistant depression. One of the last line treatments for that is neurostimulation, what's called repetitive transcranial magnetic stimulation. And in those people who otherwise don't get better from other types of treatment for depression, it actually seems to be effective in about 50% of people, but there's another 50% that are still treatment resistant. Now, it's not too far in the future that we could potentially use MEG to say, okay, here's the particular neural markers, neural indices that predict someone being very receptive to that kind of neuromodulation, neurostimulation. So I think MEG has a really great future in, distinguishing different disorders with overlapping symptomatology, as well as in the use of kind of precision medicine for new and emerging treatments like brain stimulation, neurostimulation, as well as others like psychedelic therapies.
So lastly, what's the ultimate goal for MYndspan in the future?
Yeah, so our ultimate goal is to help people understand and optimize their brain health. One of our mission statements is better brain health for everyone, and the key to that is accessibility. So the ultimate goal is to be in as many locations as possible at a price point that allows people to monitor their brain like they would do an annual MOT or car service checkup for your car. But yeah.
Okay. Well, thank you both for speaking with us today. We've really enjoyed hearing about your work utilizing MEG, and thanks again for your time, and we'll probably catch up with you again soon when we know more.
Absolutely.
Thank you very much.
Thank you.
Thank you.